Lesson 6-2 radical expressions. By the end of this lesson, and this is part 1, the goal is to be able to write equivalent radical expressions. So we know in a radical expression, we're going to have exponents that are fractional, we have square roots, cube roots, or other type of roots. So as we work on this lesson, here are a few reminders on the vocabulary. It looks a little bit different. So we have the radical sign, which is the square root symbol. The root number, also known as the index number. If it is a square root, it's just insinuated as a square root if there's no index number there. The value underneath the radical symbol is called the radicand. So there's a couple pictures with labels to kind of help us out. We will be using the product property of squares. That just means if you have whatever factors under the square root, you can break them apart and just have square root of a times square root of b. Similar for the product property of cube roots. If you have the cube root of ab, you can break it up as the cube root of just a and the cube root of b. Something to keep in mind as we're working on this lesson is a reminder of what the perfect squares are and what the perfect cubes are. This will be helpful when we are writing equivalent radicals. So like for example, to remember that 9 is a perfect square, and I can write that as 3 squared. Also that 125 is a perfect cube, and I can rewrite that as 5 to the third power. Things like that is going to be helpful as we simplify these expressions. So here in the first part, example 1, we're going to write equivalent radical expressions. So as we work on this one, let's work at example A. What is an equivalent expression to the square root of 63? So using the product property of square roots, I can express the square root of 63 as it breaks up in 2 factors. So 2 factors that can get me to 63, keeping in mind of a perfect square, is 9 and 7. So if that is a perfect square, I can also write it as the square root of 9 times the square root of 7. Well, since we know that 9 is a perfect square, the square root of 9 is simply 3. 7 is not a perfect square, so I'm going to leave that as square root of 7. So this is my simplified answer for the square root of 63. What we learned in the previous lesson is I can also express the square root, so I'm going to put an or here, as a exponent that is fractional. So I can say 9 to the 1/2 times 9 to the 1/2 times 7 to the 1/2. That is also another way to express a square root. And 9 to the 1/2 is equal to 3. Since 7 is not a perfect square, I would just keep it as 7, or the cube root or square root of 7. Okay, moving on to the next one. Write in an equivalent expression of the square root of 2 to the 7th power times 2 to the 5th. So when we have powers that are greater than whatever the cube root, square root, 4th root, 5th root, whatever it is, we are going to try to rewrite those so that we have factor radicals that would simplify a little bit more. So what does that mean? So I can rewrite square root of 2 to the 7th times 5 to the 2nd. I can rewrite this as the square root of 2 to the 6th times 2 times 5 squared. So you might ask yourself, why did I do 1 to the 6th power and just the 2? Remember, if there is no exponent, I can put an exponent of 1. And why did I have this 2? Because this is a square root. I want all my powers to be divisible by 2. So in this case, from here, if I have 2 to the 6th power, I can really write it as 2 to the 6th over 2. Remember, the numerator is your power on the base. Your denominator is the root number, which means I can also write 5 2 over 2, or 2 to the 2nd power squared. And then I'm going to put this last one over here, which is 2 to the 1/2 power. From here, I can simplify a little bit more. 6 divided by 2 is 3. 2 divided by 2 is 1. And this other base 2, I'm going to keep it as a 1/2. So if I simplify this more, 2 to the 3rd power is equal to 8. 5 to the 1st power is just equal to 5. And I have 2 to the 1/2. I'm going to take my coefficients, which are the ones without an exponential exponent. I'm going to multiply those. That gives us 40. And this other 2, I can just write it as the square root of 2. So this is an equivalent expression to the original, written in simplest form. Okay, let's check another example. It's asking what is equivalent to the expression for 1/8 of square root of 1,280. So this one includes a coefficient, which is 1/8. That's not under the radical sign or the radical symbol. So I'm going to leave that as 1/8. I can break up this radicand and think of how can I break it up, what perfect squares are in there. It's kind of like thinking of prime factorization. So if I have 1,280 and I want to break that into prime factorization, I know that I can have 2 times 640. To get 640, I could have 64 times 10. I do know that 68 is a perfect square, or sorry, not 68, 64. This can break up into 8 times 8. To get 10, I have 2 times 5, and those are prime factors. So I'm going to pause right here as far as factoring. So then I can rewrite this as 1/8 multiplied by the square root of 2 times 2 times 5 times 8 times 8. I need a pair of every factor to get out of the radical sign. So I have a pair of 2's and a pair of 8. So if I want to simplify this more, I can have 1/8. I have to leave my coefficient out front as it is. I'm going to take out one of the 2's, also one of the 8's, and I still will have the radical sign with 5 underneath. At this point, I can take all of these values and simplify. So 1 times 2 times 8 is 16, and then I would have in the denominator 8. 16 over 8 is just 2. So this entire value for this one is just 2, and then it's the square root of 5. So this is my equivalent expression, or the most simplified is 2 square root of 5. Okay, let's look at the next one. What is the equivalent expression of 1/2 of square root of 32? Again, we have a coefficient of 1/2. We're going to take this radicand right here and simplify that more using prime factorization. So to get 32, one thing I can do is 8 times 4. I know 4 is a perfect square because that is 2 times 2. And to get 8, I can break that into 4 and 2. And then this 4 can break down to 2 times 2. So another way I can write this is 1/2 of, I have a total of 1, 2, 3, 4, 5 2's. 1, 2, 3, 4, 5. Whoop, added one too many. And I need a pair to break out from under the radical sign. So I have 1, 2 pairs. So this is 1/2 times one of the first sets of 2's, another set of 2, and then the square root of 2. So if I simplify this portion here of 1/2 of 2 times 2, 1 times 2 times 2 is 4. 4 over 2 is just 2. And then I still have the 2 under the radical sign. So go ahead and you give it a try with the try-its, and then just check in with me to see if you got the correct answer.